Getty Images, we've spent the last 2 centuries fighting a war we didn't realize we were losing. Since the mid-19th century, our entire philosophy of urban living has been built on one word: sterilization. Driven by the fear of disease, we paved over the earth, chlorinated our water to the brink of stagnation, and hermetically sealed ourselves inside glass and steel boxes. We operated under a single, dangerous assumption that biological sterility equals public safety. But as we look at the state of our modern cities and our own health, we're realizing that by trying to shut nature out, we've actually broken something fundamental. Welcome to the era of the holo-bient city. This isn't just a new way to build, it's a total paradigm shift in how we define a metropolis. In biology, a holo-bient is a host, like a human, plus all the symbiotic microorganisms living in and on it. Today, we are beginning to see the city itself as a holo-bient, throbbing, metabolic ecosystem where the built environment and the microbial world are inextricably linked. The glass and concrete aren't inert, they are the skin and bones of a living organism. If we look at the air you're breathing right now, we can see the architectural effect in action. In modern high-rise offices with sealed windows and mechanical HVAC systems, we've created ecological filters. These buildings exclude the rich, diverse bacteria from soil and plants and replace them with something much more intimate: us. In these sealed environments, the primary source of biological material is the human occupants. We are living in a human microbial cloud of skin flakes, respiratory droplets, and gut microbes. This creates a biological monoculture that is far more susceptible to pathogens. Contrast that with naturally ventilated buildings. When we open a window, we allow an influx of environmental taxa like Methylobacterium and Sphingomonas. These old friends, as scientists call them, dilute the concentration of human pathogens. This dilution effect is critical because a diverse microbial environment is more resilient. By sealing ourselves in to save energy, we've inadvertently created immunologically impoverished zones that leave our immune systems prone to dysregulation. This disconnect from the soil is a primary driver behind the explosion of chronic inflammatory disorders, from asthma and allergies to autoimmune diseases. But the microbial influence goes far deeper than the air we breathe. It's also hidden in the very arteries of the city, our subway systems. These subterranean biomes are high-velocity channels where the microbiomes of millions of people are forced into proximity. Recent studies like the landmark survey of the Hong Kong subway show that commuters are the primary vectors here. Each subway line actually has its own distinct microbial signature, influenced by its depth, its ventilation, and the specific commuter cloud that travels it. While most of these microbes are harmless, these transit systems act as massive mixing vessels, making them essential. 1. Health checkpoints for monitoring the spread of respiratory pathogens or antibiotic resistance. And speaking of infrastructure, there is a silent multi-billion-dollar crisis eating our cities from the inside out. It's called microbially induced concrete corrosion, or MICC. In the dark, oxygen, poor depths of our sewer sulfate, reducing bacteria thrive in the sludge, producing hydrogen sulfide gas. As that gas rises to the top of the pipe, a different group of bacteria, sulfur oxidizers, takes over. They convert that gas into biogenic sulfuric acid. This acid is so potent it dissolves the glue of the concrete, turning solid structures into a soft, non-cohesive mush. In some cases, a pipe designed to last a century can lose its structural integrity in just 10 years. But here's where it gets incredible. We are now learning to use the microbes' power to fix the very damage they cause. Material scientists are engineering self-healing bioconcrete. This material is embedded with dormant bacterial spores and nutrient packages. When the concrete eventually cracks and water seeps in, the spores wake up. Through a process called biomineralization, they consume nutrients like calcium lactate and breathe out calcium carbonate, effectively growing a limestone seal to repair the crack from within. We are moving from a world of dead materials that we must constantly repair to living materials that can heal themselves. Shutterstock, this biological intelligence is also transforming how we handle waste. We are moving away from the old linear model of consume, pollute, and discard toward a circular metabolism. Modern wastewater plants are evolving into water resource recovery facilities. One of the biggest breakthroughs is a process called anammox. Traditionally, removing nitrogen from wastewater is incredibly energy intensive, but anammox bacteria perform a metabolic shortcut, converting ammonium directly into nitrogen gas without the need for massive amounts of oxygen or external carbon. This discovery is allowing us to create energy-neutral water cycles that were previously thought impossible. Even more futuristic are microbial fuel cells. These devices use exoelectrogenic bacteria, microbes that can literally transfer electrons to an external circuit as they consume organic pollutants. While we aren't quite ready to power the grid with sewage, these cells are already being used to power remote sensors in our sewer networks, creating a self-sustaining nervous system for the city. This nervous system is already saving lives. Wastewater-based epidemiology has become our most effective early warning system. By analyzing the gut of the city, we can detect the Orban resistome, the collection of antibiotic resistance genes in the population, long before they show up in hospitals. In 2024 and 2025, This technology was the front line against H5N1 avian influenza. Wastewater sensors detected the virus in 13 U.S. states, often weeks before clinical cases were confirmed in humans or livestock. It allowed for precision public health, targeting interventions exactly where they were needed most. As we look to the buildings of the future, we see probiotic architecture. The old way was to use toxic chemicals to kill 99.9% of germs, which only created vacant niches for the most resistant pathogens to occupy. The new way is competitive exclusion. We are designing bioreceptive materials, porous ceramic tiles, and special concrete formulations that are pre-seeded with beneficial bacillus spores. These good microbes colonize the surfaces of our homes and offices, consuming the dust and organic residues that pathogens rely on. We are literally gardening our indoor environments to support our health. We are even seeing the rise of living facades. Buildings like the BIQ house in Hamburg use glass panels filled with microalgae. These algae grow 10 times faster than land plants, absorbing CO2 and sunlight to generate heat and biomass for fuel. These buildings aren't just carbon neutral, they are becoming carbon negative. We've even discovered new strains of cyanobacteria, nicknamed chonkus, that grow at lightning speed in high CO2 environments. By engineering these into engineered living materials, we can grow structural bricks that permanently sequester atmospheric carbon. Even our history is being saved by microbes. In places like the Vatican and the Pisa Cathedral, restorers are using biocleaning. Instead of using harsh chemicals that damage ancient stone, they apply specific bacteria that eat the sulfate crusts and historical glues, leaving the priceless art and architecture underneath completely untouched. The 20th century attempt to engineer the city as a sterile, abiotic machine was a mistake. It gave us allergies, crumbling infrastructure, and massive carbon footprints. But the unseen architects, the trillions of microbes we tried to exclude, are ready to become our greatest allies. The future of the city isn't just about faster internet or taller skyscrapers. It's about building an alliance with the microbial world. The city of 2050 will be metabolically active, self-healing, and intrinsically supportive of life. Because the future of the city isn't just smart, it's alive. If you want to see more on how we're re-engineering the world through biology, make sure to subscribe. And let me know in the comments, are you ready to live in a probiotic city, or does the idea of living buildings still feel a bit too sci-fi?